So this is June 2019 paper. Question number one says the rate equation for the reaction of a bromoalkane with hydroxide ion is this one, like R KRBR. And by the way, rate equation, like in the rate equation, we always write down the rate equation for a slower step, isn't it? We always write down the rate equation for the slower step, right? So, like it means that in the slowest step, only one species is involved. That's why they have written only one substance, that is RBR. The bromoalkane that is hydrolyzed according to the rate equation is most likely to be like, what do you think? It's going to be one bromo hexane, or do you think that it's going to be one bromo 2 methyl pentane, like then 2 bromo 2 methyl pentane and 2 bromo 3 methyl pentane? So first of all, you can see this. It's a primary halogenoalkane, right? It's a primary halogenoalkane, and if you can see this, 1 bromo 2 methyl pentane. Pentane is this. It's a
Yeah.
1 bromo and 2 methyl. It's a secondary halogenoalkane. 2 bromo 2 methyl pentane means that 2 bromo and 2 methyl. So I would say that it's going to be 3-degree halogenoalkane. Okay, and again I would say that it's going to be 2-degree halogenoalkane. So if you remember, the 3-degree, that is tertiary halogenoalkane, used to give us SN1 mechanism. You remember, it gives us SN1 mechanism. And you know, in SN1 mechanism, this mechanism occurs in two steps. In the first step, bond breaking takes place, and in the second step, bond formation takes place. Since we know that bond breaking is the difficult step, so it's a slower step. So it means that in step number one, only one substance is present. So that's why it's going to be C. So the answer, sorry, it's going to be, it's going to be C, 2-bromo 2-methyl pentane, because it's a tertiary halogenoalkane. And in a tertiary halogenoalkane, like it would be giving us SN1 mechanism, and in SN1 mechanism, in step number one, the bond breaking is going to take place. Like I mean to say, if I would be telling you this one, so first of all, this is going to break down and this is going to be positive, and in the next step the OH minus would be attacking on this positive center carbon. So that's why in the first step only one substance is present, so they have included the one thing in the rate equation. That's why answer is C. Okay, are you getting my point, what I'm saying?
Yeah.
Or should I draw the mechanism?
No, I can. Yeah, I understand.
Okay. Which method is most suitable for comparing the rate of hydrolysis of a primary iodoalkane um, and a tertiary iodoalkane in aqueous silver nitrate? So what do you think? Like basically they're asking about the rate. They are asking about the rate. They are going to do a comparison between the rates. So which factor I am supposed to look at? Like I should look at the pH, I should look at the measuring the change in mass, or I should look at the measuring the time to form a precipitate. And by the way, they are going to add silver nitrate. Of course, we know that silver nitrate is going to form a precipitate with the both. Like we will see a yellow precipitate, isn't it? Because it has an iodine. Whether we have primary whether we have primary and whether we have tertiary, we have an iodine. So they both will be forming a precipitate. The color of the precipitate will be yellow. And of course, both precipitate will be taking different times. It's the common sense. Both precipitate will be taking different times. So if they both will be taking different times, it's mean that the answer C is correct. The answer C is correct. Measuring the time to form a precipitate. Measuring the time to form the precipitate. Then in 3, then in 3, the chemical equation and the rate equation for the reaction of iodine with excess propanol in the presence of an acid catalyst are shown. Which of the following sketch graph is correct for this reaction? Since we know that it's going to be first order, right? With respect to propanol, it's first order. With respect to H plus is also first order. So which is correct for the first order? You know that in a first order, when the concentration is doubled, so the rate is doubled. When the concentration is half, so the rate is half, isn't it? So what do you think? And also, and also there is nothing like iodine is not present in this equation. So I would say that it's going to be zero order. Are you getting it? Because this is not involved in a rate equation. Because and also I can say that it's gonna be I2 raised to the power zero. I2 raised to the power zero, isn't it? Because anything to the power zero is one. Anything to the power zero is one. So means that the order of reaction of iodine is zero. It's gonna be zero order. Okay. So zero order means that if you will be doubling the concentration, 4 times the concentration, multiple the concentration of iodine, the rate will not change because this is zero order, right? So what do you think? What is supposed to be the answer? Yeah, it's a good question.
D.
The answer is going to be, you are saying D for doctor or B for ball?
B. Ball.
B for ball is correct. Yeah, that's why. Because, the concentration is changing. 1, 2, 3, 4, 5, 6, 7, 8, 9. The concentration is changing, but the rate is not changing. It's constant. Yes, this is going to be zero order. The Arrhenius equation is this one. ln k is equal to minus EA over R into 1 over T. Okay. The activation energy EA is determined from the gradient of the graph shown. So gradient is equal to, of course, y upon x. Gradient is equal to y upon x, right? Or the x is on the graph R. The x is on the graph R. Yes, the x is on the graph R. This is going to be constant, by the way. Okay. And they are saying that this is the gradient. So, of course, what's left? What's left? 1 over t and ln k left. 1 over t and ln k left. So, uh, 1 over T, that's going to be the temperature. It's going to be on x-axis, right? It's going to be on x-axis. And also, ln k would be on y-axis. Y is equal to mx plus c. Have you ever seen this equation? Y is equal to mx plus c. It's on the
Yeah,
y-axis.
it's the gradient
Yeah,
equation.
exactly. It's a gradient. Should be on x-axis. It's a constant. So y is equal to mx plus c. So y equals, that's why C is correct. Question number 5. What are the signs of the entropy changes at 273 Kelvin when water freezes? Entropy of the system and entropy of the surrounding. Freezing means what? It's an endothermic system, right? Freezing, we are going to decrease the temperature. Freezing means we are going to decrease the temperature. So what do you think? What would be the effect on entropy of the system and also on the entropy of the surrounding?
It's gonna be A. The system is gonna be negative. The surrounding is gonna be positive.
Yeah, exactly. Surrounding is positive. Surrounding is positive and system is negative. You know why? Because system is absorbing energy. System is absorbing energy. Okay, so the entropy of the system is going to be negative. So A for apple is correct. Because freezes, the particles are going to compact. They are not going to move. Entropy is going to be lower. When entropy decreases, it's going to be negative. Negative, negative. We have two options, A and C. System and surrounding, they are opposite. If the entropy of the system is negative, so the surrounding would be positive. That's why A for apple is correct. Which are the Bronsted Lowry acids in the following equilibrium? Since we know that, you can see it has lost its proton. I'm talking about this one. So what I can say, it's a proton donor. It's a proton donor. When it's a proton donor, it's a Bronsted Lowry acid. It's going to accept a proton. It's a proton acceptor, right? Proton acceptor. But they are not asking acceptor one. They are only asking an acid, and it can lose proton. Again, I would say it's a proton donor because it has a positive charge. By the way, it cannot accept. So, what's the answer? Exactly. B for ball is correct. Ability to give hydrogen as having positive charge in a titration of hydrochloric acid with aqueous ammonia. Which indicator would be most suitable to detect the endpoint? Refer to your data booklet. Litmus, bromocresol purple, phenolphthalein, alizarin yellow R. Basically, indicators are pH dependent chemicals. They change their color on the basis of their pH. So ammonia is a weak base and hydrochloric acid is a strong acid. Okay. So, um, you know, it's going to be B, bromocresol blue. This indicator is most suitable for this titration. The thing is that why A is incorrect, litmus paper, like azolitmin, because it's not going to change its color sharply. It's not going to change its color sharply when ammonia is reacting with hydrochloric acid because they are going to do a neutralization at certain pH. At that pH, the litmus is not changing its color. That's why it's not suitable. This is the only thing that we have to see whenever we are going to select an indicator during an acid based titration. So that's why they are saying refer to your data booklet. I remember, so that's why I've solved it directly. So of course we have to look at the data booklet and we have to see whether like where they are going to show their pH changes according to the pH of that particular titration. And since we know that in this titration ammonia is a weak base and hydrochloric acid is a stronger acid, then in this they are asking a solution of hydrochloric acid has a pH 2. The solution is diluted to 1/10 of its original concentration. What is the pH of the diluted solution? pH of the diluted solution. Yes. You can try this, then I'm going to tell you. It's an easy,
Okay.
it's not difficult.
It's gonna be B.
It's gonna be B. How? Why? D or B? B for ball or D for doctor?
B one.
Uh, B. You're saying B, right? The answer is they are saying 1/10. They are saying 1/10. If you're saying B, so it's gonna be 1/10 means that 10 raised to the power minus 1. So are you getting 2 for this one? No. A solution of hydrochloric acid has a pH 2 and the solution is diluted to 1/10 of its original concentration. Like the concentration is decreased. The concentration is decreased. When the concentration decreases, so the pH increases, isn't it? When the concentration of the solution is going to be decreased, like I'm adding water, like somehow I'm diluting the solution. So when the solution is diluted, so the pH increases. It's gonna be 3 because it's 1/10. 1/10 means it's going to be D. It's going to be D. 1/10. 1/10. So that's why there is an increase in 1. 2 plus 1. That's why. Otherwise, we can solve it. Then they are saying question number 9. Equal amounts of three compounds were placed in separate beakers and the same volume of water was added to each. Equal amounts of three compounds were placed in separate beakers, okay, and the same volume of water was added to each, which shows the order of increasing pH in the mixture. Increasing pH in the mixture. They're adding water, right? They have added same amount of water into each beaker. Let me tell you this one. See this. First of all, CH3COOH. When it dissociates, it gives us this one, right? And then when I have this one, okay, so what do you think when it dissociates, what would happen? This is to be the product. And then we have CH3COONA. We have CH3COONA, right? So for the CH3COONA, since it's an ionic compound, by the way, okay, it's gonna give us like CH3 C double O negative and Na positive ion. So after the addition of water, so I would say that the pH of this would be higher. The pH of this would be higher because carboxylic acid is produced. So it would be at the highest. So we have two options, B and D, because carboxylic acid is produced, right? We have two options, B for ball and D for doctor. Now the thing is, we have to decide it should be this one or it should be this one. Of course, this is going to be acid. Its pH would be higher than this. That's why B for ball is correct. Because they were saying increasing pH, it should be at the lowest, isn't it? That's why I have selected B. Otherwise, B and D, they both are comparable. B and D, they both are comparable, right? CH3COONA is the salt. Its pH would be lower than that of carboxylic acid. What are the units of Kc for the following equilibrium? Since we know that in the Kc expression, we are not supposed to include, since we know that in the Kc expression, we are not supposed to include the solid ones, the liquid ones. We only put the aqueous ones, okay? The concentration of aqueous ones. So if we are going to put only silver and copper, what do you think? What would be the unit? Since we know that the formula for Kc is product upon reactant. Since we know that the formula for Kc is product upon reactant. So product means it's gonna be copper plus 2 and reactant is going to be silver plus. So mole upon dm cube, mole per dm cube divided by mole per dm cube raised to the power 2, 1 upon mole per dm cube. It's gonna be mole minus 1 and dm plus 3. B for ball is correct, right? Or question number 11. Yes. Question number 11. The graph shows the percentage yield of a product in a gaseous equilibrium under different conditions. Okay. The forward reaction in the equilibrium is exothermic with the number of moles of gas decreasing, percentage yield of product at equilibrium, and this is going to be the pressure. And they have given the temperatures 450, 350, 550. Pressure is continuously increasing. And this is going to be the percentage yield of yield at equilibrium. So when the pressure increases, so the percentage yield of product at equilibrium increases. You can see for this one, the rate is higher. For this one, the rate is lower. For this one, the rate is lower, right? The forward reaction in the equilibrium is exo or endo? First of all, we have to see this. What do you think? How can I decide after looking at this graph whether the reaction is exo and whether the reaction is endo? What do you think? Yes? Hmm. Yep. Any idea or no idea?
1 sec. Um, can you like show me the question a bit because like the question's hidden, so I can read it
Sorry,
again.
sorry.
Can you like scroll up a bit so I can see the question?
Yeah.
Is it exothermic?
Why?
Because there's like a heat like being released at like a higher temperature, at higher pressure. Does that make sense?
Basically, you can see when the temperature becomes lower from 550 to 350, when the temperature becomes lower, so we are getting more product. We are getting more products. So, oh, we remember that when we used to discuss the Lee-Chatelier principle, the principle says that when the reaction is exothermic, and if we are going to decrease the temperature of an exothermic system, so the reaction will be moving in a forward direction. So, when the temperature decreases, so the percentage yield of the product increases. So, yes, we came to know that the reaction is going to be exothermic. So exo, we have two options, option A and option B. So then we have to decide which one is going to be correct. In A, they say that exothermic with the number of moles of gas decreasing, exothermic with the number of moles of gas increasing. So how can I say with the number of moles of gas decreasing? Pressure increases, so the equilibrium increases. So it means that we have more number of moles of reactant as compared to the product. That's why the reaction is moving forward from higher number of moles to the lower number of moles. So yes, A for apple is correct. Otherwise, in other case, when we have more moles of product and less moles of reactant, when you will be increasing the pressure of that particular system, particular case, in that case, the equilibrium will be moving to the left hand side. We will not be getting the percentage yield of the product. We will be getting the low yield of the product side. Since we are getting the more yield as the pressure increases, so it shows that we have more moles of reactant as compared to the product. Are you getting my point?
Yeah.
Okay. Which is the correct expression for our lnk. So of course we have to memorize it. We have to memorize it. So the answer is going to be A. R lnk is equal to delta S system minus delta H over T. Okay. Which compound is most soluble in water? Those compound which are going to be polar. So then we have to decide which is polar, which is non-polar, which is polar and which is non-polar. 13.
Mhm. It's gonna be C
Why?
because there's the OH, so it like forms the hydrogen bonds with the gas.
Exactly, exactly. It can form hydrogen bond. Most polar. Which compound reacts with phosphorus chloride to form ethanol chloride? Phosphorus chloride, phosphorus 5 chloride, by the way, PCl5. Ethanol chloride. You know what's the formula for ethanol chloride? So it comes from D. Which two compounds react together to make the compound shown? First of all, you have to identify this compound, that what is this? What the functional group is. Aldehyde, ketone, alcohol, carboxylic acid, amine, amide, halogenoalkane, nitrile. What is this? And also, it's just it's an amide, by the way. It's an amide. First of all, it's an amide, and this portion has 3 carbon atoms, and this portion has 2 carbon atoms, by the way. So, this portion comes from, I can say, a carbonyl chloride. This portion comes from carbonyl chloride. So means that I need 3 carbon atoms. It's gonna be propanyl chloride. It's gonna be propanyl chloride. Propanyl. We have 2 options, C and D. And then this comes from amine. Amine means NH2. So how many carbons do I need? 2 carbon atoms I need. Ethanamide. Ethanamide. So it's mean that it's going to be C. For these type of questions, we are supposed to know about the reactants, like which functional group I'm supposed to make, and how many carbon atoms do I need? How many carbon atoms do I need? Now see this. The repeat unit of a polymer is shown. So can you decide, is this addition polymer or a condensation polymer? What is this? Addition or a condensation polymer?
Condensation.
Yeah, exactly. It's a condensation polymer because in addition polymer, the double bond is going to break down into the single bond. Of course, they are joined together and there is no loss of any small molecule. I'm talking about water molecule. In condensation polymer, there is a loss of water molecule. So this is going to be like that. OH and OH, right? And this is going to be like that. So when these two monomers are going to join with each other, so they will be forming this ester linkage. They will be forming this ester linkage. So which option is correct? Of course, B is correct. Of course, B is correct. Okay, then see question number 17. The retention time in a gas chromatography is the time it takes for a compound to pass through the chromatography column. A column is packed with the stationary phase that is going to be polar. Which of the following will have the longest retention time? Polar. Polar will retain the polar one. Polar will retain polar. Polar is not going to retain the non-polar one because they would be having the different phase. They would be having the different nature. Polar wants polar. Polar wants polar. So I have to see which one is going to be more polar. It would be taking the longest time in the column because in a column, The stationary phase is going to be polar. That's why they have defined, that's why they have defined. So polar is a friend of polar. So out of these four, I can say that D is correct. Why? Because it's an alcohol. It's most polar because it has oxygen atom. It's going to make hydrogen bond. Most polar. It will be having the longest retention time. A compound has the structure with a systematic name for the compound is whether it's cis or trans. What do you think? It's cis or trans? Hmm?
Um, Z.
Like cis, right? It's Z. Z
Yeah,
bole to cis.
yeah.
So cis like Z. Z, Z, we have two options, B and D. So what is this?
Um, D.
D. Yeah, hexadeck, 9 in and 1 all. It's a long chain, right?
Yeah.
It's a long chain. 6, 7, 7, or oh no, 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 no. I'm supposed to start the numbering from the right hand side because OH is the preference. 1, 6, 7, 8, 9. At a 9 position, it's a double bond, so it's 9 in. The B says 7 in. No, that's why D for doctor is correct because this is going to be the preference. Fats such as the one shown can be converted into fuels for biodiesel by trans-esterification, which compound is used as a fuel. Following the trans-esterification of this fat with methanol, methanol is an alcohol. It would be reacting with this one to form. Yep, it's from the past. It's a very easy question. Um, yeah.
Um,
CH3OH, by the way. So they will be forming A. The type of radiation used in NMR spectroscopy is, you need to know this, radio waves. Radio
yeah.
waves. Okay.